Okay, so what did we find out from the catapult last time?
Midpoint was 10.5.
Okay, so yeah. So we had catapult like this, right? And we found that it hit the ground at 21 feet, and it started at 0. So the midpoint, right, was at 10.5. So 21 halves. And the height there was 20, so the point there was 21 halves, comma. What do you mean you can't remember? Didn't you do this at home? Trusted you guys with one thing. So it was 80 inches, which in feet is
6.75.
Oh, did I do? Oh shit.
Wait, 31 or 81? You said 81.
Yeah.
So should
Isn't
be
it 81 divided by 12?
It's 6 feet.
80. I think I did this. I think we said 80, right?
Yeah.
Was that what we got yesterday? Okay, so if we slash a 4, we get 20 thirds.
Oh yeah, 6.66.
So I lied about the quarter. So we got 20 thirds of a foot, right? Just a little shy of 7 feet. Because we had a meter stick and a yard stick, and it was just a touch taller than the whole thing together. Okay, so now we can use this to get it together an equation for the catapult, right? So C of x is some kind of parabola, right? What do I know about that parabola?
Negative x squared.
Good. I know that it's upside down, and it's got 2 roots that I know of. What are those 2 roots?
0 and 21.
0 and 21. So I know I can write it as x times x
Minus 21.
minus 21 with some kind of constant k on there. And now I can use the point I know about to figure out that constant k. You guys see that? So the point I know about is 21 halves and 20 thirds. So 20 thirds is k times 21 halves times
21.5 minus 21.
minus 21 halves. Or if you have 21 halves and somebody takes away 21, you have minus 21 halves. Okay. So you get what? You got simplify. So you got 20 thirds is k times negative 441. Wait, what?
21 times 21. Yeah, 441.
Okay.
But that was a 2, right? No.
Over 4. 2 times 2, right? Totally. Don't forget how to do a fraction. Don't embarrass me when you get to calculus. All right, so then I want to multiply both sides by, no, 4 over negative 441.
Oh, okay. To get k.
Right? That'll get k by itself. So I'll get k is 20 thirds times 4 over negative 441, which is, give me an approximation for that. Negative
1,323.
negative 1,000.
Oh, sorry.
What? No.
That's the bottom. It's
Oh, that's
80
the
over-
bottom.
80 over negative. Sorry.
So 80 over
132.
equals
Negative
80 over 1323, which is approximately
negative 0.06.
negative 0.06.
Yeah.
Okay, cool. What good is this?
That's your constant K.
Yeah.
Yeah, so that's K, right? So now I can figure out where the ball's going to be, right? So let's try the trash can thing. So I want to know how tall that trash can is. So, Mason, can you catch? You want to tell me how tall that trash can is?
Did they actually do this, or did they just like
Oh no, they actually did this.
kind of lob it and then like, you know?
No, yeah. They actually did this. This is why a lot of physics and math was invented, to be able to lob rocks at people. Yeah, it used to be extremely fashionable to keep a mathematician as a pet. Like kings used to keep mathematicians as pets, basically to calibrate their siege equipment. What'd you get?
61 and a half.
Inches? Okay, so the trash can is 5, what? No way.
It's not 5 feet.
Yeah, I know, the trash can is clearly not 5 feet.
I don't know.
Did you use the wrong side? Did you measure it in centimeters?
Yes.
Okay, measure it again in inches.
You just do the conversion factor.
I'm not doing that. I don't believe in the metric system. Okay, so what we're going to try to do, right?
Basically 24.
24. Okay, so we have a trash can, right? Which is 24 inches tall. 2 feet. We have everything in feet, right? So I want to know, when is the ball 2 feet high so I can, what?
Make it in.
Yeah,
Well,
so,
wouldn't you want it a little bit above 2 feet? Isn't it? Wouldn't you just hit the? Because the 2 feet is like right where it. You would be at the ball in the.
yeah, so I'm going to position the middle of the trash can at the answer we find.
Oh, okay.
You guys see that?
Yeah. So it'll actually make it in.
Like this is what I would be doing with a castle, right? I want the rocks inside, right? Because that's where the little squishy bits are.
Yeah.
So I want to figure out how tall the walls are, which I can do with trig,
Yeah.
right? So I can figure out how tall the walls are, unless they built them crooked, right? But I can figure out how tall the walls are, and then I can just back up, lob one rock across the field, figure out the distance, right? I mean, I could just turn the thing so that it's pointing in a convenient direction for me, so I don't have to walk up to the castle to figure this out. Get the numbers off that, then look at this function and hopefully just figure out where I have to put my siege equipment to get it in.
Did they just have like a runner like that would just like hope he made it back to figure out how far the catapult was and the wall?
You can get that too with trig, right?
Oh, they have.
Once you know how tall the walls are, you can figure out this using tangent.
Yeah, but the distance, don't you need the distance? Like we measure if
So
we
you just need the distance
rocks.
between 2 people.
Yeah, you just need the distance between 2 people and 2
Okay.
sidings,
Right.
right?
Yeah.
But then once you know how tall the walls are, you can use a right triangle.
Yeah.
So you can totally do all of this math without getting near the castle, which is awesome, because those jerks have arrows and other stuff. Okay, so how do I figure out when the ball is 2 feet high? What do I do?
You
Is that when x equals 2?
Is that when x is 2 or when...
Why?
That's the height, right? So I want to know when the output of this function's 2.
So C is in 2.
Yep, so I need my
2 equals, and then.
I need my ultimate function here, right, which was 2 equals minus 0.06 times x minus 21. You guys cool with this?
When we do this, should we maybe close the door so there's no wind?
I don't think we're to that level of precision, but we can. So we have, I think, 2 is, what do I need to do with this? I need to solve, right?
Yeah.
So for x.
Okay, so we're going to have to FOIL a little bit, or distribute a little bit on this side. So I got minus 0.06 x squared plus, what's 0.06 times 21?
Something?
1.26.
1.26?
Yeah.
Okay, and then what?
Put the 2 on the other side.
Put the 2 on the other side.
And then factor it after we just.
So I get 0 is minus 0.06 x squared plus 1.26 x minus 2. And now I have to what?
Just change all the signs, so that when you turn negative.
Okay, so we may as well flip all the signs. That's a good idea. Okay, then what?
Trial and error.
No, don't do that.
Good lord.
Cram this shit in the quadratic formula,
Yes.
right? That's why they invented that thing.
Maybe.
I kid you not, that thing was invented to lob rocks. So, if you cram this in the quadratic formula, what are your A, B, and C? A is
0.06,
0.06, B is
negative 1.26,
negative 1.26, and C is
2,
2. Okay, so I got
negative b plus or minus.
X is negative 1.26 is 1.26 plus or minus the square root of
B squared minus 4 is
Squared
1.26 squared
minus 4.
minus 4 times 0.06 times
2
2.
all over
Each over
2,
Yeah, all over
2 times 0.06.
2 times 0.06.
0.12.
Okay, so then we need to simplify, right? So we got 1.26 plus or minus. Can somebody give me the contents of that square root, please? And that's 0.12 on the bottom.
Not
1.59.
Under the square root.
Oh, sorry, total square root.
it's a pretty hard input, or not hard, but tedious input.
1.1076 burning screw.
1.1076.
1076.
Sure. We're disobeying all sorts of rules about safe things. Okay, so somebody cram all of that in a calculator. I really only care about the. Yeah, I really only care about the positive one. Why?
Because it's not going to zero.
No, because I don't care about the first time it goes past 2 feet, right? Because that should be on the way up. It would lose a lot of energy if I hit the walls on the way up. Plus, you look really silly. Right, you'll have to park your catapult under the walls. Back with the arrows and the hot oil and all of that shit.
Yeah.
So we got a number for me?
No. 19.3.
19.3? No.
That's awfully low.
Did you say ignore the
Oh,
positive
wait,
input?
I said ignore the minus one.
Oh,
'Cause the minus one's going to be the first time it does it.
It's true. That's what I got.
Cool? Yeah?
Yeah.
Somebody confirm? Okay, so 19.3. Okay, so let's test it.
19 feet. What's that? X is the.
Yeah, so X is the distance from 0, right?
Yeah.
So that means that I need to park my catapult 19.3 feet from the trash can.
Yeah.
Okay, so
Did you measure where you pulled the thing to?
what?
Yeah, that was 21 feet away from.
No. Where
Oh,
you, like
okay.
where from this, like you pull from?